Hi guys, let's get into how we are going to graph these crazy rational functions. Remember, rational functions are a function in the form of a polynomial over another polynomial, so p of x over q of x, as long as our q of x doesn't equal 0. So we have a hyped up fraction that has variables showing up in top and bottom if it wants to, just can't have 0 in the denominator. So all of those different characteristics that we talked about, we're going to use those to graph them. So first one, you are going to graph your vertical asymptotes. Remember, your vertical asymptotes are the ones that go up and down. Next, you're going to do the horizontal or slant asymptote. Remember, horizontal goes left to right, like you're scanning the horizon, and a slant asymptote can either go up or it can decrease, but it's at a slant. And finally, you want to do the x and y intercepts if they exist. They don't always exist, and that's okay. After you graph those important characteristics, you next need to find some additional ordered pairs. So what you're going to do is identify x values to the left and right of each vertical asymptote. So remember, our vertical asymptotes are where our functions were undefined and things went all crazy. So we want to know what's happening on either side. We're going to plug those x values that we pick into the simplified form of the function. Remember, once you simplify, we never look back. You don't want to go back to the chaos. We're moving forward. And after we plug in those values, the output values, the numbers that we get after we simplify, are going to be the y values for the x values. So you have found ordered pairs. Let's try it out. So we are looking at our rational function, f of x equal to x plus 3 all over x squared minus 4. We need to find the domain in interval notation. Remember, to find the domain, we take our denominator, set it equal to 0. You could use the square root property, but because we are going to want to see if we can simplify, we're going to factor. Remember, we're looking for a product of a times c. 1 times negative 4 gets us negative 4. And a sum of our middle term, our linear term, which in this case is 0. Remember, for sumo, we would go and take the square root of 4, which is 2, which means that 2 and negative 2 multiply to be negative 4, and 2 plus negative 2 get us to 0, which means this guy factors into x plus 2 and x minus 2. And we're still set equal to 0. From the zero factor property, we find out that x cannot be negative 2 and x cannot be positive 2 because we set x plus 2 equal to 0 and x minus 2 equal to 0. From here, we need to write interval notation. Remember, you can always do your number line, negative infinity on the left, positive infinity on the right. The values that we found that make our denominator equal to 0, remember that we cannot be those values. So the first part of our domain is going to be negative infinity to negative 2, using parentheses because we cannot include negative 2. We need to jump over the negative 2, which means we need a jump rope, a union sign. then we are stuck in between -2 and 2. Need to jump over 2, so we need another jump rope, the union symbol, and then we are from 2 to infinity. And there is our domain. Let's go on to the simplified form. Remember, simplified form means that you take your numerator and denominator, you factor as much as you can and see if anything cancels out in top and bottom. Because our numerator is a binomial and there is no GCF, we're not going to do anything with it. We said that the denominator, the bottom, factored into x plus 2 times x minus 2. Notice that nothing, no factor, shows up in both top and bottom. So we have our simplified form. Nothing simplified. With our vertical asymptotes, remember those come from the simplified form's denominator. So anything that is in the denominator still in our simplified form, we are going to take and set equal to 0. We find that we get x equal to -2 and x equal to 2. These are both vertical asymptotes. And remember, wholes only happen if anything canceled, because nothing canceled. That means that we have no wholes. Horizontal asymptotes. Remember, for our horizontal and slant asymptotes, we need to compare the degrees. So we need the degree of the numerator and the degree of the denominator. Our degree of our numerator is 1 because we have an x to the first. The degree of the denominator, if you're comfortable doing factored form, which you should all be, factored form of the polynomial, you add the exponents. 1 and 1 is 2. Otherwise, I'm scrolling up real quick. We have a 2 as the highest exponent in the standard form version that they originally gave us. Either way, the degree of the denominator is 2 because the degree of the denominator is bigger. The denominator is in the bottom. We bottom out and we have a horizontal asymptote of y equal to 0. Just using HA for horizontal asymptote. Our y-intercept, if it exists, write any y-intercepts or any intercepts as ordered pairs. Remember, to find the y-intercept, we plug in x equal to 0 and we simplify. So if we are going to do this, because nothing simplified, you could use the original version. But because I want you to get used to using the simplified version, I'm going to use our factored version of x plus 3 all over x plus 2, x minus 2. And we are going to plug in 0 every time we see an x. So we are going to have 0 plus 3 all over 0 plus 2 times 0 minus 2. And then we're going to simplify that out. You can use your calculator if you want, but make sure that whatever you're doing is making sense. If you get some really weird number or something really big, maybe you should double check how you put that into your calculator. If I'm simplifying, 0 plus 3 gets me 3. In the bottom, 0 plus 2 is 2. 0 minus 2 is negative 2. And I get 3 all over negative 4, or negative 3/4. My ordered pair then would be the 0 we plugged in for x, and we got out negative 3/4 for y. Remember, your y-intercept is always in the form 0, comma, some number. For the x-intercept, remember that we plug in y equal to 0, which is the same thing as set your equation equal to 0. So we are going to have x plus 3 all over x plus 2 times x minus 2 equal to 0. We would multiply both sides of our equation by the denominator, but 0 times anything is 0. Otherwise, you can remember that essentially when we're finding an x-intercept of a rational, we only need the numerator, the top. And we find out that x is equal to negative 3. So our ordered pair this time, we got out an x value of negative 3 for the y value that we plugged in of 0. And our x-intercept is negative 3, 0. Before I go on to part H, let's go ahead and graph what we have, because it's said that we need to start with our vertical asymptotes, our horizontal and slant asymptotes, and our intercepts. And we found all those. So let's go ahead and do that. If you're given a blank graph like this one, the first thing that you're going to want to do is draw in your axes. So we need our y-axis, which is our up and down, and we need our x-axis. We said that we had two vertical asymptotes of negative 2 and 2. So x equal to negative 2 over here on the left side. And go ahead and label it. So x equal negative 2. And then from the origin, we need to go to the right. Those aren't showing up very well. Let's try to. Make sure that you have a dashed line, because it's not a solid line. It is a boundary for the graph, not actually part of the graph drawing itself, where you would look at the line of the graph. Okay. We also had a horizontal asymptote of y equal to 0, which happens down here on our x-axis. So not only do we have our x-axis labeled, we also have the horizontal asymptote of y equal to 0. Our intercepts that we found, we had 0, negative 3/4. And if you put 3/4 into your calculator, or you think 3 out of 4 quarters to make a whole dollar, we know that this is going to be 0, negative 0.75. Decimals may help you with your graphing. So we need to graph 0, negative 3/4, or negative 0.75. So from the origin, we don't move left or right, but we do drop down about 3/4 of the way. And there's my y-intercept of 0, -3/4. We also had the x-intercept of -3, 0. Starting from the origin, don't count 3 to the left from the vertical asymptote. We're now 1, 2, 3. So it's just to the left of the vertical asymptote. And we have -3, 0. After that, the process told us to plug in values to the left and right of each vertical asymptote. So we need 4 additional ordered pairs with at least one x value being negative for the function. Okay? We already know that x equal to -2 and x equal to 2 are our vertical asymptotes. We need 4 additional pairs. I'm going to create myself an XY chart because that will help me with the organization and help me write my 4 additional ordered pairs. If I am going to the left of -2, I get -3, which is my x-intercept. We already found that. So instead of doing -3, let's try -4. So remember that our function was x plus 3 all over x plus 2, x minus 2. And we're going to find f of -4. So x equal -4. If we plug in -4, we're going to have -4 plus 3 all over -4 plus 2 times -4 minus 2. You will need to show this work to show how you are getting all of your values, but from there you can plug this into the calculator if you would like. And if you do so, you should wind up with -1/12. If you got a decimal, -0.08333, so forth and so on, convert back to the fraction, although we will need that decimal for when we're graphing. But we found -1/12, which means the ordered pair we found is -4, -1/12. Okay, so we got -4 as an x value, -3, -2 is our vertical asymptote, so let's do -1. Again, I'm going to show my work. So if we are doing x equal to -1, plugging in -1, anytime we see an x, -1 plus 3 all over -1 plus 2 times -1 minus 2. And again, you can use your calculator if you want, but you should wind up with a -2/3. That winds up being in your calculator -0.66666666667, and so forth and so on. We get -2/3, which means the ordered pair we just found is -1, -2/3. We've already found x equal to 0 because that's when we found our y-intercept. So the next x value we're going to take a look at is 1. plugging in just like we have been. Let's scroll down just a little bit. So x equal to 1. We're going to have 1 plus 3 all over 1 plus 2 times 1 minus 2. And we wind up getting negative 4 thirds. In your calculator, it would have come out to negative 1.33333, repeating. But remember, when we are doing exact answers for the ordered pairs, we want to use our fractions. Only if they ask us for the estimate or the decimal rounding do we give them the rounding. We were supposed to find 4 ordered pairs. So far, we found 3. Remember, our vertical asymptotes were negative 2 and 2. So if we keep going to the right from 1, we would hit 2. Well, that's a vertical asymptote. So the next number we can look at is 3. So let's find out what happens when x is equal to 3. Plugging in. We're going to have 3 plus 3 in the numerator all over 3 plus 2 times 3 minus 2. Remember, you have to show this work to show that you understand how we're finding the values, and then you can plug this into your calculator. We wind up getting 6/5, which in your calculator comes out to 1.2. But remember, we're going to use our 6/5 for our ordered pair. We'll use the decimal approximations to help us graph. This work isn't particularly the most difficult thing we've made you do with rational functions, but it is the most tedious. If you drop a sign, everything's going to go to heck in a handbag. So make sure that you are watching your signs, especially when you're plugging into the calculator. Let's go back to our graph and plot these ordered pairs. We have the ordered pair -4, -1/12. So let's see, -4, -1/12 is like right there. Labeling my ordered pairs. And the next ordered pair we had was -1, -2/3. So here-ish, between 0 and 1, but negative. So that was -1, -2/3. Okay. We also had the ordered pair 1, -4/3, which we said was -1.3333333. So we're going to go to x equal to 1 and drop down past 1 because we need an extra third. So that guy right there is 1 -4/3. And then we found what happens when x is equal to 3. When x is equal to 3, we got 6/5, which was 1.2. So we're going to go to where x is equal to 3. We're going to go up 1 and then 0.2, so a little bit above it. I'm going to go ahead and label that guy like I've done everything else. So 3 6/5. And now the last part, which a lot of students forget to do, is that you actually have to connect ordered pairs. Okay. To connect your ordered pairs for your graph, remember that we are not going to cross over our vertical asymptotes. But we are going to have three different parts to our graph, which we know from the three different parts to our domain. You can always use the calculator to double check the shape of your graph, because this graph is breaking all kinds of rules. Down here, we are crossing over the horizontal asymptote. We're on the horizontal asymptote. It's nonsense. But if we're going from left to right, connecting these, we can see we're on an upward trajectory. So we're going to get as close as we can to the vertical asymptote without crossing it. And remember the horizontal asymptote, we're supposed to get as close as we can and just follow along. It's just slightly below. This guy's breaking so many rules. What a bad rational function. Okay. On the inside, the middle part, notice that we got, going from left to right, this little slope thing going on. So we're going to get really close to the left-hand side, or sorry, right-hand side with x equal to 2. And then on the left-hand side, notice that we're staying below our horizontal asymptote. And you can double check this in your calculator, but we are going to stay below the horizontal asymptote. Finally, someone is actually following the rules of the asymptotes, and it's going to get really, really close to x equal to -2. On our last side, the right side of x equal to 2, we have our 3 6/5. He's staying above the horizontal asymptote. We're going to take him really close to our vertical asymptote and then really close to our horizontal asymptote.